Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today, it's called count good numbers. So let's see what the question wants. So we actually only have like one parameter, which is an int, but it could be like the int could be like really big. So uh if we are like counting stuff, we probably need like a log n way or like some sort of smart way to like group some numbers together. But let's see. So a digit is good. Well, a digit string is good. If the digits at even indices are even, and digits at odd indices are prime. Oh, okay, that's interesting. So for example, yeah. So like for all the, wait, actually, right, right. They're counting at the back. So, oh no no no. So like this is zeroth x. It's like the second element. Like all of them are even. If you look at like first and third, they're all primes. So, it can really only be like 2, 3, 5, 7. Right. So this is not good because three. Yeah, because the zero index is has a odd digit. So given an integer n, we want to calculate the total number of good digit strings of length n. Right. So n is actually a length. Wait, but right, it could be really really long strings then. So yeah, we definitely need like some quick ways of calculating it. I'm suspecting that there's an O1 way to just like get the answer straight away. So since the answer may be large, we want to return it modulo, right? So the answer could be extremely large, which makes sense because the string could be like extremely large. Uh, right, digit string. Oh, that may contain leading zeros because it is a string. Okay. So if it is one, yeah, okay, obviously it would be 02468. So yeah, so actually one thing we can see here is that um what each digit is really independent like of any of the other digits. So we only really need to know how many odd and even digits are there. So we can calculate that from n, right? So you have like odd and then you have even. And each of them can be like either 02468 and here it could be 2357. So really we just so this is like another like combinatoric kind of question. So like it would just be uh like 4 to the power of like number of odds multiply by 5 to the number of evens. And I think that should give us the answer. Yeah, also the other thing we have to know is that when you are doing exponentiation, when you're doing like really large like exponential stuff, it's actually log n. Because like the fast way to like for exponents is like um so like let's say like you have 4 to the power of 1, and then like you find out what 4 to the power of 2 is, and then and then you can square this to find like power of 4, and then you can square this to find like the power of 8 and so on. So like that's why it is actually log n, not like on. And yeah, and it should be fast enough. So this should be a one liner, I think. Um we just get like number of odd, number of even. I think that will be clearer anyways. So number of even um right, I think what we can do is do we want to do this in one line? Surely. Yeah, let's do this as a one-liner because I think we can. So we want to find out like the number of even. So I think we can get this by dividing it by 2. Yeah, but then we always like if we have like an odd number of digits. So let's say we have like 3 digits, right? Um, well, actually, like because we start with even, if we have an odd number, we always need like to add 1 to the even. So actually, there's a very nice way of doing this. It's just like adding 1 to it, and so if it is even, it'll go to like the next. If it is odd, it'll go to the next even number. So that'll give us the amount of even numbers, and then I think if we just do n divided by 2, that will give us the number of odd numbers. So what we want is import math. So if we do so yeah, so for evens, how many ways do we have for evens? Well, it'll be just 5 ways, right? Like 0, 2, 4, 6, 8. So we can do this, and then we can also add the modulo in. So modulo is going to be int 1e9 plus 7. And then we want to multiply that by like getting the power for here as well. So we have 4 options, and then so we have like it can be like 2, 3, 5, 7 for all the odd digits. But then again, we have to modulo it. And then we want to modulo this entire expression at the end. So modulo 1e9 plus 7, and then we return it. I think that should work. Oh, wait, what is the one with mod then? I actually forgot. Math. I'm gonna search that up because there is the mod version for yeah, there's a Python. So Python power modulo. Wait, actually, it is powder, so I'm not sure why. Oh, is there no math? Oh, I think like because there are no math. So I think that should work. So we don't need math, I think. Oh, we are getting that, which is not nice. Yeah, I guess we'll just turn it into an int then. That should work. Wait, in. Well, actually, yeah. Which part is making it? This part. This is what's making it not Yeah, because 1e9 is a float, so it will be like modulo a float. Therefore, it's giving a float. But now it should work. Nice. And it's very fast as well. So yeah, I guess the takeaway is that like, if you do like if you have to like do something to the power of like an extremely large number, it's actually log n, and you can also like add a modulo and like it can calculate that as well. So yeah, thanks for watching, and I'll see you tomorrow. Bye.